The Arduino board has inputs and outputs to interact with other components. These components can be smart, such as another microcontroller, or passive elements such as an LED. In this particular tutorial, we are going to focus on digital I/Os, what they are, how to use them, and to present a few components from the Tinkercad library that can be connected to these I/Os. Inputs and outputs are physical pins, metal contacts, on the microcontroller. They can be accessed from these connectors. An input is used by the microcontroller to read data from the outside world, whereas an output is used to write data to it. The word digital indicates that the input or output data can only be symbolized with a 0 or a 1. Electrically, a digital 0 means 0 volts are ground, GND, and a digital 1 means 3.3 or 5 volts. These are also named by the words low for 0 and high for 1 or 3.3 volts. The Arduino Uno has 13 digital I/Os, and they are independent of each other. They can be configured to be either digital inputs or outputs. Their configuration is done in the setup function, and we have to use the following function to do so. The pin indicates the number of the particular digital I/O, and the mode indicates if it is either an input or an output. For example, this configures pin number 1 to be a digital input, and this line of code configures pin number 12 to be a digital output. Now, we have to learn how to read and write data through the digital I/Os. To read data, the following function is used, where pin indicates the input through which we are reading data. For instance, digital read 3 reads data from pin number 3. In a similar way, to write data through a previously defined output, we use digital write, where value is what we write through the pin. It can be either high or low. More information about digital I/Os can be found under the Documentation tab on the Arduino website. Using these three functions, pin mode, digital read, and digital write, we have all we need to write a program that turns on and off a light commanded by a switch. Tinkercad has a library of components that can be accessed through the right panel. The basic list of components is enough for now to start learning how to use them. Under this category, we can find simple elements such as resistors, LEDs, or light-emitting diodes, slide switches, and more complex elements like a DC motor. Let's start by connecting an LED to the board. For doing so, we need the LED and a resistor that protects the LED from burning out for excess of current. The LED has a positive and a negative terminal called anode and cathode, respectively. The cathode connects to the ground, GND, and the anode connects through a resistor to the digital output that controls it. How about the switch? The switch has 3 terminals. The middle one connects to a digital input to read data from it. One connects to the GND, and this one connects to the 5 volts pin. When the switch is in its left position, the middle terminal is connected to the GND. In this case, when we read the data, we obtain a low. If the switch is in its right position, the middle terminal is connected to the 5 volts, and we will read a high. For the program, we start defining the digital I/Os we are going to use. LED pin 13 for the LED, and input switch 2 for the switch. And a variable switch state, which will be used to save the data that we will read from input 2. We can assign it an initial value of 0. Then, we configure the LED and the switch as an input and an output respectively. Now we need an if structure to turn the LED on when the switch is on and to turn it off when the switch is off. We read the data from the input switch using digital read and save it in switch state. If switch state is high, we turn on the LED using digital write, writing a high in LED pin. Else, we turn off the LED writing a low in LED pin. Now let's run the code. The LED is off, and if we change the state of the switch, it turns on and off infinitely due to the loop function. Now let's change the switch by a push button to see how it works. For doing so, we have to erase the switch and its connections to the Arduino board. We will need to add to the working area the button and a resistor. The button has 4 pins, but we only need 3 of them to make it work. We connect one of them to the GND through the resistor. We connect another to the 5 volts pin of the Arduino. And finally, we connect another one to the digital I/O number 2, which is the one that our switch was using. So now we can modify our code. Actually, it is the same, but let's change the word switch to the word button so we do not get confused later. Now we are ready to run the code. If I push the button, the LED turns on, and when I release it, the LED turns off. It works, but sometimes when I push it and release it fast, it does not work. This is a problem we are going to deal with in future tutorials.